4, oke. And then?
Plus 7,
Mhm.
10.
Oke, you know, udah kelihatan ya patternnya ya. You found one number and then the next number will be uh, you add 3 ya
Ya.
after. And then to go backwards berarti sebelumnya dikurang 3 aja. So you have 1 and then -2, -5 and so on. Jadi jeda antara the difference between each number is always 3 ya. And then
Ah,
next the now the third set is the set that uh, all numbers when divided by 3, the remainder is 2.
8,
8,
11,
11,
14,
ya, and etc. ya. Sebelum 8, before 8.
5,
5,
2.
2, and then negative 1, berarti -1 ya. -1 and so on. So they all make up, like they all combine together, create they made up as a integer ya. Nggak ada yang, nothing is left behind from this. So and you notice that not a single number belongs to more than one sets in this case. Like 3 just belongs to this one, the first set. Yeah. And but not in the other 2 sets like that. So that's why we call it partitions. So this whole thing apa namanya makes up integer. Same goes with if we try to divide it into 4 sets. Yeah. We can do partitions of a number, integer. When we talk about number, it means integer, by dividing it into 4 different sets. It's like we talk about, we can do it in a way that we can gather all numbers. When divided by 4, the remainder is 0. When divided by 4, the remainder is 1. When divided by 4, the remainder is 3. Like that. So if we want to do partitions of an integer set by dividing it into 4 sets, we use modulo 4. That's what it means. Ya, jadi modulo itu this. Ya. We create a definition like this. Ya. So in for any integer n, let's say, yeah, a is this is called is congruent to, yeah, is congruent to. So a is congruent to b modulo n means that n will divide a minus b. Notice that all the numbers inside the same sets, yeah, the difference is always 3. Ya enggak? Ketika, let's say the modulo, we talk about modulo 3. Yeah. So the difference between each number is always 3. Ya enggak? Yeah. So this is just, we call A is congruent to B modulo N is when N divides A minus B. This is to highlight when we say congruent, it means that these two numbers belongs to the same set of modulo 3, like that. So any number that belongs to the same set, they are congruent.
Okay.
And we define congruent like this. Yeah. So let's say we can say 2 is congruent to 8 modulo 3 because 3 minus 2 is 6. Yeah. So, and 3 divides 6. So we can say that. Like, let's say this 2, 2, and 8 are on the same set. Yeah. When we do partitions of integer into 3 different sets, like that. So question, let's say we have modulo 11 instead. So when we talk about modulo 11, you try to imagine you are dividing integer sets into 11 partitions ya. Jadi ada 11 sets gitu. Now check, is 131 congruent to 32 modulo 11?
Yeah.
Yeah. Why?
Karena 131 minus 32 is 99, and that can be divided by.
Yeah, so 11 can divide the difference between 131 and 32. So it means that they belong to the same class of partition modulo 11, yeah? And Same goes with this, yeah. Y is 131 congruent to -1 modulo 11. Because the same. Because 131, the difference between 131 and -1 is 132. Yeah. 132 is 11 times 12. So 11 can divide the difference between these two. Yeah. So this is the concise definition of congruent. So if you want to check two numbers are congruent modulo n, you just have to check whether n divides the difference between these two numbers or not. Gitu. Is that clear for the concept of congruence? Sorry, ini harusnya bukan M ya, berarti N. This one, the book use N, so I can change it into N aja. Nanti diganti. Any questions so far?
No.
No, okay. So this is what we discussed before. And we call this, yeah, we define Zn as a set of integer modulo n containing all element of residue class modulo n. Residue class is like, basically we described, Z3 is the way we describe integers, but only using the residue class modulo 3. So let's say Z3 contains 0, 1, 2. 0, 1, 2 here is representing all numbers. When being divided by 3, the remainder is 0. So 0 here is actually representing a lot of numbers. 0 here. Yeah. We usually, sometimes people, instead of writing 0, 1, 2, they write it like this. Yeah. Ada, sorry. This is like this one. 0, 1, 2. Just to make it clear that 0 here represents a lot of number. Berarti 0 here represent -3, 3, 6 gitu ya. It's in here. It's packed in here. And then 1 is representing -2, 4, 7, and extra. 1. So, and then 2 is representing -1, 5, 8, and extra. Okay. So, 0, 1, and 2 is called the residue number. So, like, this is like the, apa ya? So, the residue numbers. Yeah, so we call it that. Okay. All element in Z3 represent its residue class. Okay, that's that one I already explained. And then you need to know in order to solve problems regarding congruent, you can do modification. Modification has to follow these properties. Okay, let's say A is congruent to B modulo M. Then you can add both A and B with the same number and they'll still be congruent. That's the first property. The second property is that you can multiply A and B with the same number and the result will still be congruent modulo M. And then, but be careful with division. Division, you cannot just divide A and B with the same number. It's not always going to be congruent, again, modulo M. So for this one, for division, you have to be, the one that I can guarantee, or the theorem guarantees to use that if we divide A and B with the same number, they'll still be congruent, but it's no longer modulo M, but instead modulo M over the HCF of C and M. Do you remember what HCF is?
Yeah, highest common factor.
Okay, so highest common factor between the number that you use to divide both numbers and the M, yeah? So like that. So the modulo is reduced that way. For example, here I give you the example. Let's say we know that 14 is congruent to 8 modulo 6, yeah? And if we add both numbers with 2, we know that 16 is also congruent to 10 modulo 6, yeah? Both belongs to the residue class, what was it? 4 ya, berarti ya. 4. And then if we multiply them by 2, let's say, if we multiply them by 2, we got 28 congruent with 16. And this is true, yeah, because 28 and 16 itu belongs to the same residue class, which is what? 18 and 16 belongs to which residue class, do you think?
Um,
Or,
null.
null kah? I don't think so. They're both not divisible by 6. Nol itu all numbers that is divisible by 6 karena remaindernya 0.
Oh,
Hmm. Or you can check it using the definition ya. 28 minus 16 is berapa? 12 ya. And 6 divides 12. So this is guaranteed ya. This is also true. If we add by 2, they're still congruent. We multiply both by 2, they're still congruent. But let's see. If we divide both with 2, so we get 7. Is 7 congruent to 4 modulo 8, modulo 6? Do you think 7 congruent to 4 modulo 6 or not?
no.
No, yeah. The difference between 7 and 4 is 3. 6 does not divide, it's not divisible by 6. So it's not congruent. Okay, so you cannot divide both with the same number, and they're still be congruent unless you divide it with a number that is relatively prime with 6. Just now, what we did is that we divide both with 2. 2 and 6 are not relatively prime because the HCF of 2 and 6 is 2. Yeah, it's 2. Relatively prime number, the HCF of two relatively prime numbers is 1. Jadi harus HCF-nya harus 1 biar bisa langsung dibagi. If this is the case, so what we do is that we can divide, but the modulo we divide juga. Jadi kayak 7 is going to be congruent to 4 modulo 6/2. Yeah, in this case, this one. And this is correct. Like that, yeah. So the property says that we can add with same number, still be congruent, multiply with the same number, still be congruent. And if we want to divide with the same number, make sure that number is relatively prime with our m, the modulo. If it's not, then reduce the modulo by dividing it with the HCF of the number that we used to divide with the m. Gitu. Is that clear?
Yeah.
Okay, so these properties is going to help you to modify any congruent. Okay. Now, this is the application. One of the application of, there's so many application for congruence. One of them is to predict the remainder of division. So what is the remainder of 100 after being divided by 7? Ini kalau yang angkanya kecil, if the number is still small, you can use a division algorithm to predict the remainder. Let's say we can express 100 as 7 times 14 plus 2. So the remainder is 2. Yeah. But what if the question is like 10 raised to 10? What is the remainder of 10? 10 to the power of 10 after being divided by 7. Now, this is a bit hard to imagine. So we use, in this case, we can use congruence to solve this problem. We know from start that 10 is congruent to 3 modulo 7, right? Yang ini benar kan? 10 is
Yeah.
congruent to 3 modulo 7, all right. So we use this fact to simplify So 10 raised to 10, because 10 is congruent to 3 modulo 7, 10 to the power of 10 is also going to be congruent to 3 to the power of 10. Oke, jadi kita bisa mengecilkan angkanya gitu. Using this congruence that we know. So 10 raised to 10 or 10 to the power of 10 is congruent to 3 to the power of 10 modulo 7. And we know that we can express ini 3 raised to 10 as 3 raised to 3 times 3 plus 1 ya. Now, this one we can also separate. Jadi kalau ada, if we have an exponent, addition of exponent using exponent law, we can separate them. It becomes times, like this. So, and then if we have a product law for exponent law, 3 times 3 means we can modify it as 3 to the power of 3 to the power of 3 ya. Nah, ini kan sama aja dengan kali, ya enggak? So this is this. Basically using exponent law we can modify it like this. Why do we have to modify it like this? Is because we know that 3 raised to 3 is congruent to 27, right? 27 is basically negative 1 ya harusnya ya. Okay. Let's see. 20, 27 is congruent to berapa modulo 7 kira-kira? 27 is congruent to something modulo 7. What do you think that number is?
6.
6. Yeah, 6 can. Also, you can express it as -1. 6 sama -1 sama ya. Jadi, I prefer the smaller numbers. The smaller you use, the better it is.
Yeah.
Okay, so because 27 is congruent to -1, so we can change 3 raised to 3 as -1. Ini harusnya -1, sorry. -1 raised to 3 times 3. Jadi kita bisa, we can reduce the congruence like this. So -1 raised to 3 is just -1 ya. -1 times 3 is -3. -3 is congruent to what? Modulo 7. By adding 7, -3 plus 7 is 4. So this is congruent to 4. Modulo 7 ya. There is a mistake in my apa namanya notes before. Okay, so we know right away that 10 raised to 10 has a remainder of 4 after being divided by 7. The answer is, the remainder is not 3, but 4. Gitu. That is how you use congruence to predict the remainder of number. Usually it's a big number in the form of, apa namanya? In the form of exponent. Okay, and divided by the number. Gitu. Any questions so far?
Yeah.
Okay, let's try practice. Do we have okay, maybe I'll give you the theorem first that you can use so that you can practice. This one. So some of the theorems we can use to simplify. Yeah? Just now, like we modify. We use that theorems to help us reduce the congruent. Yeah, so that we can deal with smaller number and smaller number. The key is that usually try to change the congruent. Yeah, change it into small number. Usually, this preferable small numbers that you can use is 1 or -1. But sometimes you can use just any small numbers. The smaller it gets, the better. Gitu ya. So this is the theorem that you can use to help you modify congruent. The first one is Fermat's little theorem. So Fermat's little theorem says like this. Let A be any number relatively prime to a prime P. Then A to the power of P minus 1 is always going to be congruent to 1 modulo P, like that. So just remember that P has to be prime and A has to be relatively prime to P. So A cannot be a multiple of P, yeah, like that. Let's say, for example, yeah, let's say we talk about modulo 7, okay? And we know that 5 and 7 are relatively prime. So I know for sure, based on this theorem, that 5 raised to 6, yeah, 6 from 7 minus 1, is going to be congruent to 1 modulo 7, like that. So this is how we apply this theorem, yeah. Another one, maybe I'll give you an example. Modulo 11, let's say. 11 is a prime number. And maybe I'll choose 12, yeah. 12 raised to something equal congruent to 1. What do you think that something is?
10.
10. Gitu ya. So we know for sure 12 raised to 10 is congruent to 1, modulo 11. You can use this theorem later to your own advantage ya, to modify congruent, to find the remainder of a division. Also, some people also applied, if we multiply both sides with A, let's say, we multiply with A, we will have on the left side A to the power of P minus 1 times A. So we have A to the power of P instead. And on the right side, we have A. Yeah. So this is another version of Fermat's little theorem. A to the power of P is congruent to A modulo P. You can use this one or you can use this one, no problem. Like they're both the same thing anyway. Gitu. So this is like 5 to the power of 7 is congruent to 5 modulo 7, like that. Okay. Any question so far?
Mm.
What about Kevin? Hello, Kevin, are you there?
No questions yet.
No question yet. Okay. Have you learned about congruence before?
Not yet.
Not yet. Okay. So this theorem, and next is I'll tell you about Wilson theorems. Yeah, Wilson theorems give you this theorem. Let P be a prime. So P has to be a prime, and then P minus 1 factorial is always going to be congruent to -1 modulo P. But later on, they make a general approach here to Wilson theorem that turns out it can also work for any integer n. So we can use this instead. For any integer n, we have n minus 1 factorial is congruent to -1 modulo n. Okay, this is going to be helpful whenever you have factorial in your congruent. So if you have factorial, you know that, oh, this is the time for me to use Wilson theorem. Yeah. So the keyword is that this like the factorial operator right here. Yeah. So n minus 1 factorial is congruent to -1 modulo n. Let's say it's like this. 6 factorial is congruent to -1 modulo 7, like that, yeah. Or if we deal with modulo, let's say 10, so 9 factorial is congruent to 1 modulo 10, gitu ya. We know for sure about that because Wilson theorem guaranteed it. Yeah, he already proved that it's correct for all integer n. So we can just use it to our advantage, gitu. Any questions about this one?
Itu bukannya -1 ya?
Oh iya, -1, sorry. Ya, -1. Atau berarti in this case, if -1 modulo 7 is just the same as 6 ya. 6 modulo 7. If you don't want negative number. Because residu kelas kan biasanya yang positif. Jadi 0, if residu kelas for 7, residunya itu berarti kan yang dibilang 0, 1, 2, 3, 4, 5, 6 gitu. And then kalau 10 berarti kan 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 ya. Jadi sometimes you can write it that way. But because for modification, like I said, it's preferable to use 1 and -1 instead. That's why the theorem says -1 instead of di sini apa P minus 1 ya, instead of P minus 1. You can always say P minus 1, but instead it use -1 gitu. Okay, let's continue. I think this one you can hold it for a minute. We can do some exercise. Okay. Let me choose. For Nijita and Kefan, you can try all this. Try the first one, yeah, and give me the answer. And for Brooklyn, because we discussed this yesterday already, you can do question berapa ya berarti? I'll add more questions for you. Try this one. Six. Let's say. 7, 7. Oke. Try this one. Buat Brooklyn yang nomor 6 ya.
Ya, Bu.
Do you get it?
Bu, jawabannya
Ya,
satu ya?
satu.
Is it one?
Oke, let's see. Pakai pakai apa? Boleh dijelasin nggak, Bro?
Aku coba pakai
Mhm,
yang tadi ibu jelasin.
mhm.
I forgot the name, tapi aku itu
Ya, pertama diapain? Jadi kan, you know
eh
that,
7 mod 5 kan itu berarti sisanya dua. Jadi
sisanya, hold on. Mod 5, 7 mod 5,
dua.
2. Oke, 2, 3, 3, 3 ya.
Iya.
Terus,
Terus 111 times 2 power of 111 times 3.
tuh, 111
11.
times 3.
Jadinya 2 pangkat 3 pangkat 111.
Oke, 2 pangkat 3.
Jadinya 8 power of 333. Sorry, 8 power of 111.
Oke,
And then 8 is basically 7 times 1, and the remainder is 1.
7, 8 is basically what?
No, no, sorry. No, no, I got it wrong. Sorry.
Oke. Bisa dikecilin ya. 8 itu berarti 3 ya.
Ya, tadi aku kira modnya 7.
Oke. Nah, ini bisa dilanjut dari sini. Almost, almost. For Nizita and Kevin, you got it?
Karena confused.
Okay. What is it that you're confused about?
Kayak, I don't know, kayak too congruent to uh, 12 mod 10, right? As for the first question.
Hold on, hold on. 2 to the power of 10 congruent
Hmm.
to something modulo 10 gitu.
Yeah.
Okay, so you basically try to find this ya. So, what do you do first?
Ibu ini bisa langsung nggak pakai yang 2 pangkat 10.
Oh, 2 pangkat 10 masih kecil ya, boleh sih. 2 pangkat 10 masih apa bisa di... Oke, boleh. 2 pangkat 10 berapa berarti?
1024.
Oke, oke, boleh. Kemudian 1024 modulo 10,
Kan itu 100. Remindernya 4.
4. Oke, bener ya. Jadi kalau yang angkanya kecil bisa langsung dihitung, no problem. And do you notice here, if we trying to find the remainder of some number divided by 10, it's actually the last digit. Yeah, the last digit. The question is actually asking you about the last digit. So sometimes the question is, instead of asking it this way, they ask about the last digit of a number. Jadi find the last digit of a number 11 time raised to 11, maybe kayak kayak gitu ya. Jadi kayak kalau questionnya asking you about last digit, just keep in mind that that is the same questions as finding the remainder when a number is divided by 10 ya. This one. Now, yang kayak gini berarti belum apply apa namanya? Belum apply the theorem ya. So, let's continue with beberapa exercise setelahnya nih ya. So that we can apply the properties and theorem that you've learned. This one. Let's try number 2. Jadi coba dikecilin ya. Jadi find ini modulo 7 means that I want you to find they are congruent to what? Modulo 7. When I say congruent to what modulo 7, it's like find the residue number. Residue numbers means number between 0 until 6 ya. They're actually congruent to what? Karena kalau modulo 7 berarti pilihannya hanya ada 0, 1, 2, 3, 4, 5, or 6 gitu. Can you do it? Or do you want me to explain it to you further? Again, maybe you need more example?
Yang ini dikali dulu atau gimana?
Boleh, boleh di-reduce dulu masing-masing, boleh banget. Atau dikali dulu juga boleh. Jadi, it doesn't matter. Jadi, boleh dikecilin dulu. Kalau aku sih enaknya jangan dikali ya. Karena by multiplying it, you'll get bigger number. Jadi, di-reduce dulu, dikurangi dulu. Kira-kira di sini berapa nih? Ada yang langsung bisa dihitung nggak? Something modulo 7 antara 1002 dan 560. Which one that you can find the remainder very quickly?
560.
Which is?
80.
Nah, hati-hati nih Sita. Remainder sama hasil bagi beda.
Nol.
Nah, jadi ini tuh congruent to 1002 times 0, which is congruent to 0. Modulo 7. That's it. Coba yang ini. Find this number modulo 33. Jadi pilihannya hanya maksudnya 0 sampai 32 ya, angka jawabannya nanti. Now, this one, I'll help you this one and then I'll give you number 4 buat latihan sendiri ya. So this one is, let me give you an example. 2 to the power of 98 modulo 33 ya. How are we going to calculate this? Okay. So, 2 pangkat 98. We try to change ya, 2 to the power of something that is closer to 33. Kira-kira apa? 2 to the power of what that is closer to, yang hasilnya closest to 33.
5.
2 to the power of 5. We know that 2 to the power of 5 is 32 ya. 32 is congruent to what? Modulo 33. Ya, 32 sebenarnya 32 ya. But if we are trying to change it into smaller number, it is equal to what? Sorry, it is congruent to what?
-1.
Ya, benar. -1. So, try to make try to modify 2 to the power of 98 as 2 to the power of 5. 98 itu try to express 98 as 5. So 98, we know that 98 is 5 times berapa tambah berapa. Ini division algorithm ya bagian ini ya. 5 times berapa plus berapa?
19. Wait. 19 plus 3.
19.
16?
19 plus 3.
Berapa Iris?
19 times 19 plus 3.
19 plus 3 ya. Oke, we try to express it that way. So 5, 9 times 2, 3. You get it?
Ya.
Kan ini pangkat ya. Kalau pangkat berarti I can write it this way. It is from 2 raised to 5 times 19 ya ini. 19 plus 3. I can separate the 3, so it becomes times 2 raised to 3. And then 5 times 19 as exponent is like this. I can write it like this. Oke, jadi yang ini bisa diterima nggak yang sini? Sampai sini?
Ya.
Oke, modulo 33, we know that 2 raised to 5 is -1. It's congruent to -1. So this is -1 raised to 19 times 8 ya. Modulo 33. -1 raised to an odd number equals to -1 times 8. Modulo 33. So ini -8 ya. -8 modulo 33 is the same as what? Try to come up with non-negative. -8 is congruent to what modulo 33?
25.
25. So that is the answer. Yeah. Try number 4 by yourself. Okay, Brooke, you got it?
My answer is -3 or 2.
Ada dua?
Yang
Negatif.
positif
Karena
2.
ya sama ya, karena kongruen ya. Oke, so you got 2. How do you get it from here?
3 power of 2 times 55 plus 1.
2 times 55 plus 1. Okay.
Uh,
Modulo 5. This is
5
3.
is basically negative. Ya,
Di mana?
9. Oh enggak. Ya udah bener.
Oke. And then
9 power of 55
9.
is basically -1.
Okay. So -1 times 3. Modulo 5, which is 2 ya?
Yes.
Modulo 5. Oke. Jadi answernya karena remainder, we cannot have negative as remainder. Jadi remaindernya berarti hanya 0 until 4 ya. 0, 1, 2, 3, 4. Jadi stick to 2 instead of -3. Oke. Nice, Bu Green.
Bu Rika.
Yes.
Sarah katanya nggak bisa datang hari ini. Dia mau izin minta recordingnya nanti, Bu.
Oh iya, boleh nanti Ibu posting recordingnya di grup ya.
Oke, thank you, Bu.
You're welcome. Gimana nomor 4? Bisa nggak Iris, Kevin, Nizita?
I'm doing it right now.
Okay, tell me if you got it. Udah?
Wait, absolutely.
Is it 1?
1? Oke. Let's try. Jadi ini 5. Pendekatannya gimana? How would you change 5 to the power of 30? What number is 5 to the power of what? Closer to 62? Or multiple of 62?
Sebenarnya closestnya kan 5 to the power of 2. Tapi itu kayak the gap was so big that I made 5 to the power of 3.
Nice.
1 to 5. And then aku made it what is it called yang 3 lines itu
Apa? 3 line?
eh kayak sama dengan quote unquote
Oh, it's congruent. It's
ya
congruent.
congruent to 63. Terus
Ini wait, ini 63 ya?
ini
Atau
ini tadinya
oh iya, 1 ya. Oke, 1 sebenarnya berarti.
terus
63 berarti 1 ya. I'll write as 1.
ya udah terus itu jadi 1.
Oke, nice. So try to come up when you apa namanya? It's a good thing when you try to imagine 5 to the power of what closer to modulo 62 is that you can also if there is no 5 to the power of something closer to 62, you can work with the multiply of 62. So let's say 62 is 1 to 4, yeah. 1 to 4. Oh, I can work for 5 to the power of 3 is 1 to 5. 1 to 5 is close to 1 to 4. So you can use that also. No need, kadang nggak harus 62 aja, bisa multiply of 62 to find the closest power, ya. So that we can reduce the number. Okay. Any questions so far, guys?
No.
No? Let's continue ya. Nah, ini mungkin yang faktorial biar kita bisa apply tadi Wilson's theorem. Yang faktorial, let's say number 18 ya. 18. Let's discuss yang 18 factorial ini. Jadi number 7. What is 18 factorial? What is the remainder of 18 factorial that is being divided by 437? Ini kebesaran ya kayaknya ya. Oke. Oh, bentar. Let me actually take this moment to explain to you about inverse. Okay, there is one thing about inverse that I need to tell you. So inverse, any operation has inverse. Let's say when we talk about addition, when we talk about inverse, we'll talk about identity element also. So identity element, I'll start from there. Identity element is a number, yeah, one number from the entire number set. When you add that number when you perform the operation, in this case addition, with that number, the value doesn't change or the value remains the same. We call that number as identity element. So in addition, the identity element is 0. So because we know that for all number, if we add with 0, it stays as that number, 2, gitu ya. -5 plus 0, -5, gitu. So identity element is 0 in addition. And we define inverse itu sebagai pasangan setiap number. So inverse is each number will have their own inverse. Inverse in this case means that if we have a number and we operate it with that number, we will get identity element. We will get 0. So in this case, in addition, the inverse of 2 is -2. Yeah. Or like the inverse of -5 is 5. Karena when we add the number and its inverse, the result is the identity element, in this case 0. Now, if we talk about identity element and inverse, it depends on the operation. For addition, they have their own identity and inverse. For multiplication, let's say, they also have their own identity element. And based on that identity element, every number will have their inverse. So multiplication. Let's talk about multiplication operation. What do you think is the identity element with regards to multiplication operation?
1.
1, yeah. So we know that identity element is 1 because all numbers, when being multiplied by 1, it remains the same as that number. Yeah, the value doesn't change. So in that case, let's define inverse. So ini inverse ya. Inverse of 2 with regards to multiplication operation is what?
1/2.
Yeah, 1/2.
Yeah.
The inverse of 3/4 is?
4/3.
Yeah, so you get it, yeah. Identity inverse. Now, for this, when we talk about congruent modulo, they also have their inverse. And let's define the identity first. Identity-nya sama dengan multiplication. The identity-nya is 1. Identity is 1, modulo M, ya. So, but it doesn't work this way ya, karena nggak yang identity inverse dari 2 is no longer 1/2. But let's talk about, let's imagine it this way. Let's say 3 times what? You got 1 modulo 5, let's say. 3 times what number is congruent to 1 modulo 5?
2.
2. So in this case, 2 is called the inverse of 3 modulo 5. Yeah, or vice versa. 3 is the inverse of 2 modulo 5. Yeah. Okay, now this one will help us a lot with trying to reduce congruence and also solving linear congruence. Let's talk about question number 6 ya. If you are given this, ya, this kita nggak jadi ngebahas nomor 7 deh. Lain kali aja, nomor 6 dulu. What is the remainder when, let's say, you're given this number, ya, divided by 11, gitu. The way we operate it is like, we try to find the inverse of each other among this multiplication so that it's easier for us to calculate, ya. Jadi di sini kira-kira 7 is inverse-nya 7 modulo 11 berapa? This is the same as 7 times 8 times 9, 15 times 16 times 17 times 23 times 24 times 25. Modulo 11 ya. Let's try to make it smaller maybe. Pertama 7, 8, 9. So 15 becomes 4, 16 become 5, 17 becomes 6, 23 become 1, and then for 24 become 2, 25 becomes 3, 43 becomes negative 1. Yeah, I can write as negative 1, no problem. Or berapa ya? 10 ya. I can write it that way. 10. Modulo 11. Now, which one is the inverse of each other, do you think? Modulo 11. Or 7, let's say. 7, the inverse of 7, modulo 11 is what?
Um,
4.
4? No.
no, times
Berapa?
what? 8.
8, nice. So 7 and 8 are inverse to each other ya. So when you multiply them, they're equal to 1. Okay? You found it. So ini bisa dikecilin jadi 7 kali 8 bisa jadi 1. 9. What is the inverse of 9? Modulo 11.
5.
5. Nice. Jadi 9 sama 5. 4. What about 4?
3.
Yes, 4 with 3. What about 6?
6. Or 2. 2.
Huh? 2. Okay. So that's they're actually inverse to each other ya. Jadi kita bisa tahu bahwa okay, 7 times 8 that becomes 1. 9 times 5 becomes 1. 4 times 3 becomes 1. 6 times 2 becomes 1. So 1 times 1 times 1 times 1 times 1 times 10. So what remains is just 10 modulo 11. There you go.
Okay.
Okay. So inverse, this is inverse, how we operate using inverse. And actually, Wilson theorem, the reason behind Wilson theorem is also inverse. Yeah, you can actually match factorial, yeah, because like let's say we have factorial, and then you can always find the pair of inverse among these factorials numbers, and then you can reduce it like that. So it becomes -1 for Wilson theorem gitu. Okay. Any questions for this?
No.
If not, let's continue. So let's continue to congruence. Harusnya nggak congruence equations ya. So I think they limit the equations as linear aja. Jadi we start from the linear congruence. Now, instead of equations using equal signs, we have congruence. Yeah. Find questions like this, for example, find all x that satisfy the following congruence. 2 times x is congruent to 5 modulo 7. What do you think is that x? Can you find that x? What that x is?
Within 3.
3. Hah? 3?
Isn't it six?
6?
6.
Oke. 12 ya. 12 kurang 7, 5. Oke. So the solution to this linear congruence is x bukan 6 aja. Because the solution will be many. Karena ini congruence ya. It means that 2 times x, ini kalau dibaca ya, it means like, what is the solution to 2x equals to 5, 2x equals to, let's say, 12, 2x equals to berapa? All numbers that is in the same class as 5. Jadi sebenarnya ini banyak gitu. So, karena banyak, the solution is also banyak. There are many solutions. So to write down all the solutions, we write it down like this ya. X is congruent to 6 modulo 7. This is the solution. Okay. Now, what about this? So sometimes you have simultaneous equation where you have 2 equations and the variable involved are the same. Now let's say we have 2 congruents, linear congruents, and the variable involved are related, yeah, the same. What do you think the value of x that satisfies both?
Um,
Okay, let's simplify it first, yeah. So this one, for the first one, we can modify it so that we have the form of x congruent to modulo 7. So in this case, x congruent to what? Modulo 7.
Oh, 2. 2.
2. So 2, yeah. Okay, 2 modulo 7. This one, we have x congruent to
3.
3 modulo 6. Okay. Now, what is x that satisfy both? What
Oh,
do you think?
9.
9? How do you get 9? 9 modulo what?
Ya, iya. Ya, 9 aja. Karena
9
9,
aja.
9 mau 7.
9 mau 7, 9 mau 6.
3.
Hold on. Ini ya, we have a system like this. Find X that is actually that. Misal kalau dijajar nih, kalau dijajar kan berarti kan 2 modulo 7 is the same as 2, 9, what? 16, 23, and so on ya. 3 modulo 6 is the same as 3, 9, what else? Tambah 6, 15, gitu ya. And so on. Jadi 21 and etc. Yeah. So you okay, you got it 9 ya. 9 is appears same. Jadi di sini X is congruent to, but it's not only 9. The answer is a lot actually. Many solutions because this is congruent. So 9 correct, but modulo. Do you think it will repeat after what? Do you think the same number will appear after how many numbers in this case? Yeah. The next number, the next equal number will appear after.
Tiga, 6.
No, not 6.
7.
No. Coba aja ya, kalau setelah 7 emang dapat sama lagi. Kayaknya enggak sih. After 42. A multiply of 7 and 6. Okay, so after 42 ini tambah 42 aja. 9 plus 42 berarti my question is wrong. So not after 3 or 6 or 7 numbers ya, but like 9 what number comes next is like you add 9 with 42, you'll get the same number again. Jadi kayak 9 plus 42 is 51 ya. 51 will appear on both. And then 51 plus 42, 93 ya. 93 will appear on both. Gitu. Sorry, I worded my questions wrongly. So, ini ya. This is the solution. Now, there is someone who actually came up with a way to calculate this. And this question is actually the same as this ya. Misalkan I have this. X is congruent to 2 modulo 7, X is congruent to 3 modulo 6. It's the same problem as this. What is a number gitu ya? What is a number or find a number where atau when ya bilangnya, where after being divided by 7 the remainder is 2, which has, sorry ya, mending ditulisnya which has remainder of 2 after divided by 7 and remainder of 3 after divided by 6 gitu ya. So this is the same problem as this ya, sama. Yeah, but like this one is like we wrote it in a congruence notation. Okay, so usually the problem is related to this. You're given a problem like you have to guess what number is, but you're given the clue, the remainder when divided by something, the remainder divided by something. It was okay. Someone came up to a theorem to solve this problem efficiently. Yeah, the theorem is called Chinese remainder theorem, and the idea behind that is that they're trying to solve these type of questions. So, please read these questions. Yeah, Chinese general counted troops remaining after a battle by lining up them in rows of different length, counting the number left over each time, calculating the total from this remainder. Jadi kayak when they have a number of let's say troops, yeah, number of people, and when they line up and form line up 5 at a time, the leftover is what? And when they line up 6 at a time, the leftover is 7. And you are trying to guess how many numbers of Chinese people in that troops gitu ya. So that's what basically why is it called the Chinese remainder theorem. It's based on that scenario. But I don't know if it is correct or not, yeah, but it's just that the name is like that. So let's try to solve this. I'll explain to you how does it work. So let's try to solve this problem at the same time. If a general had initially 1,2,0,0 troops, at the start of the battle, there were 3 left over when they line up. Okay, so we know that there are 3 left over when they line up 5 at a time. We can express this as we can express the number of troops left or left at the end of the battle as X, yeah, let's say. X is no need for is. Let X represent number of troops at the end of battle. And now we see that the clue is like this. There were 3 left over when they line up 5 at a time. Jadi we can express that as X is congruent to 3 modulo 5. Gitu ya. 3 left over when they line up 6 at a time. So we can express that as 6 is congruent to X is congruent to 6. Congruent to 3 modulo 6. And then 1 left over when they line up 7 at a time. We can express that as this. None of them none left over when they line up 11 at a time. So X is congruent to 0 modulo 11. Okay, and we try to guess what X is. Now, the method is like this. Yeah, sebenarnya method what is it? What you can do is that maybe you can express it like this, yeah, like what we did before. So like try to name all numbers with the remaining 3 after being divided by 5. So it's like 3, 8, 13, 18 gitu ya, and so on. 23. And then try to, for this one, X is congruent to 3 modulo 6 is the same as 3, 9, 15, then 21, 27, etc. And then for this one, 1, 8, 15, 22, 28, etc. And this one is 11, 22, 33, 44, 55. Gitu ya. This is the classical way. You use like you try to find it like this by writing all the numbers. But it takes a lot of time, and maybe the first number that appears might not be the correct answers. So you have to answer it in general, representing all the possible numbers possible. Okay, so instead of doing this, if we use Chinese remainder theorem, it's like this. So we know that based on the previous let me actually explain it to you using this case first, the simple one, and then we'll go to the one with 4 congruence, yeah. Wait. Oh. Okay. Now, x congruent to 2 modulo 7, congruent to 3 modulo 6. Let's say we have this as congruent to 2 modulo 7, x congruent to 3 modulo 6. The idea is here. You have to write it like this. The modulo will be always the multiplication of this. Yeah, so 6 and 7. Also, these numbers, the modulo has to be relatively prime so that this theorem can be applied. That is the only condition that this theorem gave you. So as long as you have this number relatively prime, you can apply this theorem right away. So we prepare this like this. And then since there are 2 congruents given, you prepare 2 separate places and being split by addition like this. And then okay, and this one, yang pertama involving 2 ya. So 2 times 6, okay, 2 times this. For this one, the second congruence, 3 times all the modulo without the modulo of that congruence. So 7 in this case, because there are only 2 modulo, we write 7 instead. Okay, and then make sure we try to multiply with its inverse. So 6, yeah, 6. What is the inverse of 6 modulo 7, guys? What do you think is the inverse of 6 modulo 7? Hello? 6 times what is
6
congruent to what?
times 6.
6, yeah? So we multiply it with its inverse modulo 7. This one. This number we multiply it with the inverse, 6. And this one is 7, yeah? We multiply 7 with its inverse modulo 6. So 7 is what? The inverse of 7 is 1, ya? 1 aja, jadi nggak ngaruh. Okay? This one. So this is x is congruent to 2 tambah 2 times 6 is 72 ya. Plus 21 modulo 42. So this is how you apply Chinese remainder theorem. The procedure is like this. X is congruent to 93. So you have 93, yeah. You can reduce 93 into the reduced number, which is, so minus 84, yeah. 93 minus 84 is actually 9. Modulo 42. Now, this is an example of applying Chinese remainder theorem when there are 2 congruents involved. Okay, you see that, the method before is shorter, yeah, faster compared to this one. Okay, so that is correct. So when you have like only 2 or maybe 3, you can always still predict the solutions by yourself like this. But if you have 4 of linear congruence, the Chinese remainder theorem is way faster than using the classical method. So this one, let me explain you again. Yeah, give you an example how to solve this using Chinese remainder theorem. First, you prepare this. Yeah, x is going to be congruent to modulo of all of the numbers multiplied. So 5, 6, 7, 11. 5 times 6 times 7 times 11. Because later on, once you find a number, the next number appear will be addition of this, yeah, this product. Okay, so because there are 4 congruents, prepare 4 places. This plus this plus this plus this. The first place belongs to congruence modulo 5. The first place. This one belongs to modulo 5. This one belongs to modulo 6. This one belongs to modulo 7. This one belongs to modulo 11. Okay? So you write all the numbers in front of each module congruence, yeah? This one is 3, this one is 3, this one is 1, this one is 0. Okay? So, like that, and then you multiply it with, for every of this number, you multiply it with all the modulo that is not the modulo of that congruence. So, aside from modulo 5, so you multiply 3 with 6 times 7 times 11. For the second one, you multiply with 5 times 7 times 11. This one, you multiply it with 5, 6, and 11. This one, you multiply it with 5, 6, and 7, yeah? Okay, like that. Okay, and then, yeah, try to find the inverse of each of this. Modulo 5. So we see 6, 7, 11. If we multiply them, 6 times 7 times 11 is 462. Yeah, 462. Multiply by what? Congruent to 1 modulo 5. So we have to multiply it with its inverse. Modulo 5. What do you think is the inverse of 462, guys? You can reduce it, yeah. 462 is congruent to 2 modulo 5. So we can multiply it by 3, yeah. 3 we get 1. So this is 3. Okay. So we'll multiply it with its inverse. I need more space. This one. X congruent to 3 times 6 times 7 times 11 times 3. Gitu. Next one, try to figure out 5 times 7 times 11 is 335, 385. 385 times what? Equal congruent to 1 modulo 6. Okay. 385 is congruent to, we know that 385 is congruent to, let's say, kalau dibagi 6,
Sudah. Sorry, I think it's already congruent.
kenapa?
This size 1.
Kenapa?
I think we can multiply by 1.
Oh, 1? Oh, it is congruent 1? Okay.
Iya.
360, 26. Oh, okay, nice ya. So multiply it by 1, nice. The next one. Thank you, Nara. Next one. 5, 6, 11, 3, 6, 3, 3, wait. 330 ya? 330. Let's find the inverse of 330. Modulo 7.
It's
Mhm.
I think it's juga 1.
1 juga. Oke. Tadi nih, sorry. Tadi ini nggak cukup soalnya aku kasih ruang lebih ya di sini. 3 times 5 times 7 times 11 times 1. Yang ini 1 juga. Oke. Next one. The last one. I think for the last one, you don't have to find the inverse because it's 0, yeah? 0 multiplied with anything is 0. So the last one, okay, let me write it first. 5 times 6 times 11 times 1. Yang ini, leave it as it be because you don't have to find the inverse anyway because it doesn't matter for this one. Okay, it's gonna be 0 anyway. So that, wait. Should I change it into this or should I? So for, wait, I think let's change 0 into 11 instead so that we play it safe. 0 can be 11. And try to find the inverse of 5 times 6 times 7, which is 30, 210 ya. 210. Inverse-nya modulo 11. What do you think that is? What is the inverse of 210?
1.
1? 1 juga. Okay. Okay, so we leave it as it be ya. And the rest is just calculating. Once you find all this combination, the rest is calculating. Calculate this, plus this, plus this, plus this, modulo that. Can you help me calculate? Modulo, so this is 30, 2210, jadi 21, 23, 108.
Wait, well, I think the first one, the 3 times 6 times 7 times 11 is,
Kenapa? Yang pertama,
yeah, it should be,
the
it
inverse
should
is not,
be, enggak, it should be 1386, not
what?
462.
Oh, yang ini ya. Jadi inverse-nya
Iya,
berapa? Inverse-nya harusnya
juga 1.
1 juga. Oh, oke. Jadi di sini we have berapa tadi perkaliannya? 21 kali 6. Enggak, tadi tuh 6 kali 7 kali 11. So 3,
Wow, okay.
6 kali yang ini ya, yang ini. Bukan yang angka depan. Yang angka depan nggak dipakai. Jadi
Oh,
6
okay.
times 7 times 11 which is 4, kan 42 ya. 462 bener sih. 462.
Okay.
Ya. Jadi patokannya yang ini, angka yang di belakang ini yang kita cari inverse-nya. Because what? Kalau di mode 5 nanti dapatnya tetap 3 karena ini kan hasilnya 1 gitu maksudnya. Gitu. So, this is still this. Can you find the total calculation? Once you find the total calculation, reduce it ya. Reduce it to be mod to 310. Okay? Kayak gitu. What is it? 5.181 ya. If you reduce it by 2310, you will have 2871. You can still reduce it to 2310. 561. That is the answer. 561 modulo this. 2310. Okay, so the answer is like 561 or 561 plus 2310 or 561 plus 2 times 2310 and etc. Gitu. Any question so far? So this is, let me sums up ya. How you apply Chinese remainder theorem to solve this linear congruence problem is that the x as a solution will be in modulo of a product of all the modulo given. Yeah, so 5 times 6 times 7 times 11. And then to find the number, you have to consider all the 4 cases where this number later on, when divided by 5, the remainder is 3. When divided by 6, the remainder is 3. When divided by 7, the remaining is 1. When divided by 11, the remainder is 0. So that way, you try to separate it into 4 sections. Yeah, 4 sections where each of them will give you the remainder of each cases. Okay, so the first section will make sure that you get remainder 3 modulo 5. That way, you write 3 as the remainder and then try to multiply with the rest of the modulo to make sure that when it's modulo 6 or modulo 7 or modulo 11, it's 0. That way, yeah, because you multiply it with 6, 7, and 11. That way. That's why I include that here. Because when I apply modulo 6, modulo 7, and modulo 11, it will become 0, this section. Okay, and to make sure that I get remainder 3, I have to multiply this number with its inverse, modulo 5. And that way, I will still have remainder 3, modulo 5. Yeah, so I multiply with its inverse, which is 3. So that's what you need to do. The next section is section to make sure that I got remainder 3 modulo 6. So I write the 3 and then I need to make sure that it's going to be 0 when I calculate other modulo, which is modulo 5, modulo 7, modulo 11. So I have multiplied with each of them, 5, 7, 11. And to make sure the remainder is still 3, I have to multiply it with its inverse, the inverse of 5, 7, and 11, multiplied together. That way. Same goes with the third section and fourth section. That is for the modulo 7 and modulo 11. Yeah, to make sure I got the remainder 1 when divided by 7 and the remainder 0 when divided by 11. Gitu. That is actually how you do Chinese remainder theorem. Is that clear, everyone?
Yep.
Yeah. Okay. Maybe I will need to add one more thing, yeah, last thing before we close. We still have. Oh, okay. Yang ini, ya, for this one, the idea is that if you have quadratic congruence, let's say modulo 72, yeah. There's a hint in that. Note that 72 is 2 raised to 3 and 3 raised to 2. Yeah, by trial and error, solution discongruence will be modulo 8, yeah, and modulo 9. Okay, so the solution to this congruence, x squared plus 6x minus 31, congruent to 0 modulus 72, will also be solution to this 2, which is x squared plus 6x minus 3, congruent to 0 modulo 8, yeah, and also solution to 6x minus 31, sorry, congruent to 0 modulo 9. Yeah, keep in mind that the solution here will be the solution here. So we work from this. Yeah, we work from this. And the way we work from this is that solution to this, yeah, will be solution to, because 8 is 2 raised to 3, solution to this congruence will be solution to x squared plus 6x minus 31 minus 31 congruent to 0 modulo 2. Okay, and solution to this, modulo 9 will also be solution to this congruence modulo 3. So the way is that we have to start from this, yang paling simple. And then we move up, and then we combine these two solutions using Chinese remainder theorem to get